2012, one of my colleagues asked me, look, tell me what drives the cricketers' strike rates? I mean, how do we get this to go faster? So we started playing around with this data. The first thing that we found was that if we scrape house stat, there's a plethora of information about every single innings that everyone's ever played, and this is pretty useful. So with this, we said, let's see, when a country's players play, do they score more or less? So on average, for example, we find that South Africans score the highest, followed by Australians, and the difference is almost negligible. And India is not far behind, Pakistan is not far behind, but if you go all the way down to the bottom, players from Hong Kong, East Africa, United States, they don't score so well. Now, you don't need me to tell you that, right? That's fairly well known. On the other hand, against which countries do players play well? Well, that's not a difficult question either. Against East Africa, the run rates are pretty high. Hong Kong, the run rates are pretty high. Namibia, the run rates are pretty high. It's almost the same reverse, or the same list in reverse. And it's obviously much tougher to score against England or Pakistan or South Africa. But it's toughest to score against Afghanistan, which stumped us all. Now, of course, the answer is fairly obvious to some of you. The thing is, you don't need to score much against Afghanistan. By the time you've scored this much, the match is over. Right? But what we do know is that there is a certain amount of variation between the players in one country versus another country. So one short answer to the question, how do you get to be a better player, is just play for Australia or South Africa. No, you can't. But that's one kind of simple answer to that question. Or, for example, who is the player with the fastest strike rate? I mean, how does one get to be like the players with the fastest strike rate? Well, the player with the fastest strike rate is Johan Leo, followed by Hasti Gul, followed by Luke Ronchi. And they have strike rates, I mean, an incredible strike rate of 328, right? I mean, how does one even get to that kind of a strike rate? There's a simple formula to that. Play only 7 balls in your career. Okay, and somehow manage to hit a few sixes in the middle of those balls, you'll get to an incredible strike rate. When I went through this list originally, it was in for a bit of a surprise because I didn't recognize a single name with the sole exception of Ijaz Ahmed until I saw the junior suffix to it. And he's played 2 balls and hit 3 runs. Fantastic strike rate. Huh? I mean, 3 runs. And he must have scored it off the first ball because he would have gotten out in the second unless it was the last ball of the innings. But what it does tell us is that there's an incredible variation in the strike rate. Now, can we use this principle of variation to see if the variation between players, the variation between countries, and each of the other parameters that we have has a larger influence or a smaller influence? So, if I take all of the data that is there in the cricket field, then can we take each one of these columns and answer the question, how much variation does this contribute to? And that gives me a rough sense of whether that variation is higher or lower than another parameter, right? Now, turns out that the country that you play against has the largest impact. Okay, there's a 16% variation there, knocking off outliers and a bunch of things. I'm not going to go into the details of how this number is computed. I will later. But in other words, that quickly answers the question. If you want a team to have a really good strike rate, play against Namibia. Don't play against South Africa. Right? No, sure. But the second is somewhat interesting. It says that the ground, the pitch that you play in, has a pretty strong influence. Pick the right ground. Now, this is actionable. What this means is that depending on the team that you're playing against and the relative strike rates, you may want to choose carefully a pitch that allows for higher strike rates or lower strike rates. And that's pretty useful. The third largest impact emerges from the country that you play for, which again is not actionable. I mean, you can't just say, no, I'm no longer going to play for India, I'm going to play for South Africa, right? That's just not workable. But strangely enough, the fourth largest variance comes from the day of the week. And the interesting thing is that it's statistically significant. For some reason, players score significantly more when they play on Tuesdays. They score a lot less when they play on Sundays, when they play on Wednesdays. Now, we don't know why this is. The only thing that we've been able to figure out is that for some reason, Australia and South Africa play a significantly larger number of matches on Tuesdays than they do on Sundays, which in itself is an anomaly because Sundays are when most matches are played in general. That's the most common date of the match. And yet, this is an anomaly. Now, I've used the word significant at least a couple of times. I mean this in the statistical sense, that this is not randomness. There is a p-value of less than 10 to the minus 8, which is a pretty strong p-value. So it's not due to randomness, and we don't know why this is. But what we also know is that there are a few things that do not matter. The player does not have a significant impact. The date of the match does not have a significant impact. And there are several other parameters that do not have an impact. So this allows us to approximately answer a certain question, which is, what explains the strike rate? Right? What are the drivers of strike rate? I know that the ground or the pitch is a larger influencer than the country you play for. The country you play against is an even larger influencer than that. And this is a fairly common pattern of questions. We've seen this pattern of questions every year in our business across almost every kind of engagement. For example, in 2013, Sugna Poultry said, we want to know why our birds die. So when we place them in a farm, from the time when they're placed to the time when they're 45 days old, the proportion of chicks that reach maturity, that is one of the largest drivers of profitability in our business. What are the drivers of that profitability? The next year, a pharmaceutical company asked, we have a series of service requests that are flowing in. Some of them are flowing in far slower than we'd like. What is driving the speed at which they're moving through our system? The next year, NCERT asked us the question, what explains students' marks? Why do some students score higher? Why do some students score lower? We have a survey that has details of every single one of the students' behaviors. What can we infer from the kinds of behaviors that drive higher marks? In 2016, Star TV asked us a question, how do we increase TRP ratings? When we have a television serial, then what are the kinds of costumes, what are the kinds of dialogues, what are the kinds of scenes that we should be scripting so that that drives a higher TRP rating? This year, we were working with a bank who said, I want to know what explains the attrition rates of employees. What are the bigger drivers? What are the weaker drivers? What are the things that we should be acting on? All of these have one common theme through it. They're asking the simple question, I have a bunch of categorical and quantitative data. I would like to see which one of these has the largest influence on a certain metric, which is by and large quantifiable. That, to me, constitutes a pattern. Now, what I'm going to do is talk about how one goes about automating the answers to such questions. Not that this is a very sophisticated technique, but I purposely want to make it simple. In fact, before I proceed, let me explain a couple of things about what I'm going to do in this. First is that this is a simple tutorial. I'm not going to talk about neural networks. I'm not going to be talking about machine learning. And part of the reason is that every time I've started talking about these, people get so excited. And there's, oh, machine learning, oh, deep learning, oh, what's the next big buzz, right? And people often mistake entertainment for education. Education often comes with a lot of pain, and my focus here is not to entertain you. My focus, at least for the next 10, 15 minutes, is to teach the technique. And the second is that we will be using spreadsheets. Now, spreadsheets, as Fred Brooks put it in his No Silver Bullet talk, are pretty much the biggest innovation since high-level programming languages when it comes to productivity in technology. And let's not deride the benefits of the humble spreadsheet. It is the largest analytical package that exists across the globe, and there's a lot to be said for it. So what we'll be doing is taking specifically a spreadsheet that contains survey data from the NCERT. Now, this is a large-scale survey across classes 3, 5, and 8. They surveyed approximately 200,000 students each across the country and asked them 100 questions each on their behavior, 100 questions on the school's attributes, 100 questions on the parents' attributes, 100 questions on the schools, on the subjects, on each of the subjects. And it's almost a total of 1,000 questions for 200,000 students, a fairly detailed survey. A subset of a copy of this is at this link for those of you who are interested. You can grab it while it lasts. The data is technically public, but it's not necessarily very easy to grab. Now, let me show you what the data set looks like, and I'll zoom in until you can see it. Hopefully that's visible even from the back. Now, this has information about each student and the state they belong to. I've specifically, for the purposes of this analysis, only taken the students from Maharashtra just to keep the data set small. And the district they belong to, the gender, age, category, blah, 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 and several hundreds of columns. I've taken a subset of these columns. Now, like we did for cricket, let's answer some simple questions. The first question that I'd like to take up is, do calculators make a difference when students write the mathematics exam? Do the students who tend to use calculators at home, not during the exam, of course, do they score better or do they score worse? Now, this is very simple, right? And you all know how to do this. I'll just do a pivot table. And on the pivot table, I will take the use of calculators as one of the columns. I'll make it a bit bigger so that those of you at the back can see it. And and just for reference, let's also add a count of the number of students. So just that's the count of students. And let's finally take the total number of marks, the average of the marks that they're scoring in mathematics. That's not the count. We want the sum of this field. And, oh, sorry, not sum. I really want the average, don't I? All of these are on a scale of 0 to 100. And let's get it to a level that's more easily understandable and also format it so that we can read it fairly easily. So what I can see is that the students who, yes, do use calculators tend to score higher in mathematics than they do, than students who don't. No, that's a fairly straightforward conclusion, no different from any of the other kinds of analysis. Now, of course, the second question that you need to answer is this statistically significant or is it just randomness? But we'll come to that later. Now, let me ask the same question of the use of, before that. One thing that I do want to mention here is that what we have at the moment is a correlation. We have a set of people who've said, yes, we use calculators. We find that they also score higher. Now, the logical inference is not necessarily the statement that students who use calculators tend to score better in mathematics. It could just as easily be students who like mathematics tend to use calculators and the others don't. Right? We don't really know what is cause and effect. Now, however, the fact that correlation is not causation is often misinterpreted. A lot of people therefore say, so it's useless, right? I don't have causation. No, that's rubbish. Correlation is useful in itself. That's throwing the baby out with the bathwater. Supposing somebody tells me that they tend to use calculators and they use calculators a lot, I can therefore conclude that it's more likely they are doing well in mathematics. It doesn't necessarily mean that one causes the other, but we do know that there is a co-occurrence, and co-occurrences can be useful as well. So we need to be very careful about the interpretation of correlation as not causation. The underlying assumption that many people erroneously make is that causation is the only useful thing. No, quite the contrary. Correlation exists for a pretty good reason. Let's take something else. Now, what about computers? Does the presence of computers make a difference to mathematics scores? Well, that's pretty easy to do. So let's get back to Excel and look at computers, which I should hopefully find reasonably soon. Computer use. Let's take that and let's get rid of computer use. And I find that students who don't use computers actually tend to do significantly better than the students who use computers. Okay, strange. Now, I'm not going into the details of how and why and whether this has any underlying meaning from an education perspective. This is what numbers tell us, and I've offline done the calculation on the statistical test. This too is statistically significant. The good part about big data is that you rarely get to results that are statistically not significant, not that common. The sheer volume of data means that it's applied across such a large sample, which is in many cases the population in its entirety. You don't often get results that are wrong. What you could do is misinterpret those results, and we'll talk about that in a bit. Now, the question is, which of these is a larger influence? Well, let's see. Those who don't use computers versus those who do use computers on a daily basis, what is the difference in their marks? So that's 38 and that's 30. So that's approximately an 8 percentage point difference in marks when it comes to use of computers. But on the other hand, let's get this out and let's bring back the use of calculators and ask the question, what difference does the use of calculators versus not using calculators make? It's only a 3 percentage point difference. In fact, less than 3 percentage point difference. Now that tells me that if you're using computers and you're using calculators, there's probably a decent chance that the use of computers is hurting more than the benefit of using calculators, that this is the stronger influence. And we can start laying out the entirety of these influences, which is precisely what we did. And this is a website that shows you the various influences of each of these factors. So for example, how does the use of calculators affect mathematics marks, reading marks across each of the subjects, and so on. Now, if I drill in specific, let's take one area. So watching TV. Does watching TV make a difference to the students' marks? It turns out that if you watch TV once a week, that's about the sweet spot. Those who watch TV every day don't do so well. Those who watch TV only once a month or never watch TV don't do so well. That is at least when it comes to science as a subject. The same is true when it comes to social sciences. Once a week seems to be the sweet spot. But reading, however, is a very different thing altogether. The more you watch TV, the better you do in reading. Okay? So if you want your kids to be journalists, then just put them in front of the television. On the other hand, if you look at mathematics marks, then it completely destroys mathematical ability. Right? Now, this is particularly striking because what we find is that the students who watch TV every day score worse than the students who never watch TV. And the students who never watch TV are typically the ones that don't have a TV in the household in the first place, which means that they're economically worse off. And if the students who are watching TV every day are doing worse than even these kids, then we have a significant negative impact of watching TV. Let's take a different area. Let's say playing games, for example. How does playing games make a difference? Oh, that's great. The more you play, the better you do in mathematics. So, want your kids to become engineers? Send them out. Get them to play more. And on the other hand, playing games a lot doesn't really help reading ability. I mean, between never playing versus playing a bit, yes, sure, it helps. But as long as they play at least once a month, go out and get some fresh air, it's fine. We don't really need them to keep playing to have improved abilities in reading. And all of these can be aggregated to answer the question, what really makes a big difference to the total marks? And the short answer is the parents. The parents' education and the parents' occupation are the single biggest drivers of marks, and everything else is a significantly secondary parameter when it comes to this. Now, you'll notice that the analysis that we did in humble Excel is all that it takes to get to this result. Of course, we also need to do a certain amount of statistical testing, and some of you may be familiar with the famous XKCD strip, which talks about statistical significance. I'm not going to try and explain the joke. Just search for XKCD and significance, and you'll catch up on it. But it does help us answer the question, which parameters have a larger influence, which parameters have a smaller influence, and we can apply this to each of the questions that we'd seen in the past. So, for example, if I take cricket again and answer the question, what makes a larger difference to the chances of winning, right? Turns out that there's a difference between whether you bat first or bowl first. So for teams that bowl first, the person who gets nominated as the player of the match, which is effectively the strongest player in the team, has a larger influence, and the umpires make a pretty big difference. But it turns out that if you're batting first, that is, if you're winning by runs, then the umpire has a huge significance. And now we can, of course, click on this and see who are the players and who are the umpires that actually have that kind of an influence. In fact, I'm quite tempted to see if we can do that. So if I ask the question, when winning by runs, or no, let's take wickets, who are the players that actually have contributed to significant wins in the IPL? And the answer roughly looked like this. Jack Callis has had a much stronger impact than Pollard. Dhoni has had a moderate influence, but where's... Gilchrist has had a reasonably good influence, but A.B. de Villiers, despite his incredible match-winning performances, has actually had less of an influence in winning the match than some of the lesser players out there. Now, this works across all of the other areas that we spoke about. So, for example, when we talked about poultry mortality, we were looking at what is the impact of the farmer experience on poultry mortality. Makes only about 8% difference. The temperature, which is controlled by the fan usage, had the second largest influence. Our client said, look, that is what we believe to be the single largest factor. The kind of cooling that we use, and the use of air coolers we've found has a huge impact, and it does. But it turns out that there's one parameter that makes an even larger difference, and that is litter material. If you place coir on the floor as a litter material, it is so vastly superior to anything else that in itself just gave a 13 crore return to the bottom line in 1 quarter. Or this pharma company that said, why are our service requests delayed? So when we looked at that and put together this piece, ignore the top part even though it looks nice, the biggest difference comes from which division has the highest, or which division is sending the service request. Now, between different divisions, the variation in speed of service requests is so huge that that's what's making a difference. The country where it comes from does not make a difference. So it's not geography, it's function that is really driving the change. The entity makes a difference. The region which we've covered, again, does not make a difference. Of course, this answer may vary from site to site, may vary from customer to customer, may vary from type of organization to type of organization. So you pick each of those subsets. In fact, let's see if I can pick one of these and see if there's a difference. Okay, no, there is no data for this subset. But we start filtering this and exploring to see if there is a difference from area to area, effectively just automating the same algorithm that we applied for that subset of data and getting the results again. Or for Star TV, for instance, the serial May Come In Madam has a lead character called Sanjana, and it turns out that she does well in every costume except jeans. Anytime she wears jeans, the TRPs just tank. She also does quite well when she comes with this co-star called Chedi Lal. She does extremely well in night song sequences. So it is pretty obvious as to how you go about scripting this television serial, right? So I must apologize to whoever has been watching this serial if you think that the quality, or if it became more monotonous after 2016, then you probably know whom to blame. Or this retail bank who said, we want to understand what drives attrition. And what we find is that engagement parameters have a larger impact on attrition. The educational background of the people makes very little difference. It doesn't matter where you come from. It does to a certain extent matter how you do, but what matters more is how you engage. And how does one quantify engagement? Well, things like how often you are in office, attendance definitely makes a difference. But interestingly, corporate social responsibility initiatives, how much you participate in fun club activities, how many library books you borrow. These are surprising indicators, and in fact, stronger indicators than even performance of many of the factors that drive attrition. Now, what we've been doing all of this while is taking, one simple pattern. What explains the marks? And we've gone through a simple algorithmic approach. Step 1, take all of the columns. Step 2, identify the variance across this column. Step 3, rank by these and say that the top ones are important. Of course, I'm skipping a lot of the nitty-gritties behind it, which is let's get rid of the outliers, let's test for statistical significance, and so on. But ultimately, we have a relatively simple technique. But the point is not the technique. The point is the breadth of its applicability. And the breadth of applicability of these patterns is there in several other areas. Let's take forecasting, for example. So if I were to look at price forecasting as a class of forecasting problems. Now, how does one go about doing it? Well, you try very hard to get the data, and then you apply a series of models, and then you pick the best model and go with it, right? That's a fairly straightforward pattern. Completely automatable, because all you need is the various time series, and against each of those time series, you take the training data and the test data, apply each of these models, look at the quality and accuracy of these models, whichever is the best consistently, go ahead. And this particular price forecasting result, it turned out that neural networks were consistently outperforming every other kind of model. Now, this is not generally true. For instance, we find that ARIMA outperforms in a number of good scenarios. Ensemble models, of course, which take the best of breeds across, usually do a pretty good job. But the point is that the approach is straightforward. You blindly apply across a large class of algorithms. You can always keep adding new algorithms, and the system tells you what is the best, and you go with that. Or, for instance, when it comes to cluster detection, right? This was used for a manufacturing company that said, we want to understand when an employee leaves, whom are they going to take along with them? So help me find, based on the email communication between people, who are the closest to a particular person. And I know that when this particular person leaves, there's a chance that he might take the rest of that group along. So I will therefore protect that group from attrition. Now, in this particular case, it's again fairly easy to identify that cluster, and you can almost visually see some of these clusters forming. The system identifies those and throws out a result. Very limited room for human analysis, and this again is a fairly automatable class of problems. This is what I'm seeing increasingly, that the analyst's role is less and less of execution of analysis. It is more and more of the system doing the analysis, and the analyst is interpreting the results of the analysis. There are enough patterns of automation even today, and increasingly more so, that lead to a change in the analyst's role towards interpretation, which begs the question, what are the challenges that we are seeing on interpretation, and what are the solutions that we see towards this? Well, the biggest challenge that we're seeing right now is the growth of black box models. Black box models are increasingly more accurate. For example, we were working with a telecom company, and they said, we want to look at churn. So what does it take to be able to identify which of our customers are churning, what are the drivers of churn, and stop that. So we built a series of models. The model was primarily based on two factors. One, if I lose a customer, then thanks to all of the overhead of KYC and cost of acquisition and so on, it takes me approximately 80 rupees to get a new customer. On the other hand, what I can do is send a simple top-up to my customers of just 5 rupees. And not many of these people will take it up. Maybe only 1 in 8 will take up that offer and start using it. But even then, I can retain 1 in 8 customers, which means that by just spending 40 rupees, I can retain a customer. So given this economics, that it takes me 80 rupees to acquire a new customer, but I can afford to, I roughly waste about 40 rupees, can I get a targeted model to find out whom I should be sending this offer to, so that I just prevent the people that are likely to leave from well, leaving the network. And if we start with a decision tree model, which roughly looks like this, is a slightly anonymized version. It says that if the customer has not called in the last 15 days, they are almost certainly likely to leave, if at all they haven't left. So make sure you target them. On the other hand, if the customer has made an outgoing call in the last 4 days, then don't worry about them. It's nowhere near enough time for that. If their last outgoing call was within the last 5 to 14 days, then if they've made more than one recharge in the last 3 months, don't worry about them. If they've recharged for more than 65 rupees, don't worry about them. And if not, that's when you need to target them. So this gives me an ability to improve the overall cost by about 39%. That's based on the original calculation. So that is, if I did nothing, then I would lose all the customers, I would reacquire them, that costs a certain amount. This saves me 39% of that particular cost. And this is a white box model. I know why this works, because these are factors that we can intuitively relate to. The business team understood this. They said, yes, we can work with this. At this point, we made a mistake. We stupidly showed them a better model. Now, the trouble with these models is that if I take a black box model, I can't really explain how this works, right? So we put in a neural net, we put in a support vector machine, we put random forest. And support vector machines, which was not the best model that we finally came up with, ended up giving a 66% cost. So the project manager said, yes, that's exactly what we want. We love it. Let's go with this. And the management couldn't understand head or tail of it. And the whole thing got canned. Interpretation of these models is a pretty big thing. It's not just about saying, trust me, I've got witch magic that will solve your problems. It's also about helping the other person understand why this works and communicating it effectively. And that is increasingly becoming the role of the analyst when the machines are taking over the role of analytics itself. Now, how does this work? Let me take one specific example, specifically that in the space of unsupervised learning, which is particularly tough. Let me take an example of behavioral clustering. So we were working with a media company, and they said, what we want to do is segment India demographically. So I know that Bilaspur and Hyderabad actually have very similar characteristics, even though they are geographically very disparate. But why are we treating them as north and south and having sort of the non-Hindi speaking geography and the Hindi speaking geography as the only channel segments that we have? We need to segment, and we need to segment based on their characteristics, not based on geographic proximity. So how does one do that? So we said, let's play around. And this is not the one, this is not the one, this is not the one. Sorry, where am I? Okay, I've got to open the right window. Okay, let's take this one. So we said, let's take all the censuses. There are several census data sets, socioeconomic caste census, the usual census of India, there is the district census and so on. Across all of these censuses, we have information around demographic characteristics like rural population, female population, literacy levels. We have religious mix, Hindu, Muslim, Christian, etc. We have asset ownership, how many people have LPG cylinders, how many people have electric lighting, and so on. And if I pick all of these districts and pick a subset of features, so let's say I'm going to choose based on demographics and asset ownership. So that is, I'm going to select a subset of these columns and use that. Did I select asset ownership? Yeah. And use that to implement clustering using some algorithm. Let's just take k-means since it's familiar enough and apply the clustering. Now, this is going to give me a result which says that, firstly, let's start looking at the tabular result, which says that this particular district belongs to cluster 5. This particular district belongs to cluster 4. Now, what does this even mean? How does one go about understanding these clusters? The good part is this is geographic. So in this particular case, we have one more basis of understanding, which is a simple map-based visualization. So I can see on a map what this looks like. And I say, oh, okay, there are 6 clusters named 0 to 5. And there's one big cluster in the center. There are these greens that are scattered across. There's segments across various areas and so on. In fact, what I'm going to do is change the parameters to include all of the segments. Include religious penetration also, and recluster. That's going to give me a different clustering mechanism in a few seconds. Yeah, that's closer to the one that I'm familiar with and that we finally used. So I can see that the Northeast is a slightly different region. The UP, Bihar belt seems to be fairly homogeneous as a group and so on. But I still need help interpreting these clusters. How do I label these clusters? Well, one way of looking at it is to say, if I take each of these clusters and all of the parameters that I've used for clustering, how do each of these clusters fare on those? So, for example, if I take, let's say, literacy percentage, Cluster 0 has low literacy. Cluster 3 has high literacy. Now, that's pretty striking. Now, if I do this for each of these, then I may be able to get some names for these clusters. So I may call cluster 3 the literate cluster, which also has high asset ownership and also tends to have high purchasing power. That may be one way in which I could come up by doing this, but I have to wade through a lot of mess to be able to do that. Can we simplify it further? Well, what we could do is say, look, system, tell me what is the most striking or the most unusual features in this. So allow it to go back and forth on a slider to point out the most unusual elements. And when I start putting in the most unusual elements, it says that the most striking feature is that cluster 4 has a high Christian population and cluster 5 has a high Sikh population. Okay, what is this cluster 4 and cluster 5? Cluster 5, it turns out, is entirely made up of Punjab. Okay, so that's a very distinct entity in itself, and yes, obviously it has a high Sikh population. Cluster 4 is made up of certain states in the northeast, and they tend to have a high Christian population. Fine, so these are distinct clusters. Let's move on. We find that cluster 3 is characterized by a low rural population. In other words, it's the urban areas. So let's put in cluster 3 and find that it's in around Chennai, lots of Kerala, Bombay, Pune, Delhi, and so on. So yes, those are the urban areas. So I have a name for at least one cluster, which is cluster 3, which is distinguished by the fact that it's primarily urban, and so on. And we can start interpreting each one of these clusters progressively one after another to understand how exactly these clusters are behaving. Now, what we're doing here is interacting with the model. We're trying to learn more about the model. The intent here is not to make the model smarter. The model is pretty smart. We have ways of optimizing the model to death. What we don't have is a way of making humans smarter about the model. Reasoning around why these models work, what models work better, and what's behind the scenes, so that my poor project manager could have convinced the client that the better model was in fact a better solution. What should you be taking away? I'm going to skip all of this. What should you be taking away from all of this? Actually, no, I'm going to give you one more example I still have time. So we were working with the World Bank, and one of the problems that they had was, look, what we'd like to do is help people understand how innovation is clustered across countries. So we have a whole series of indices and metrics that we're using to help to evaluate the technological innovation of countries. And based on this, we've classified them into a bunch of categories. What we'd like to know is how they fare on various parameters. So help us explain to people what clusters they fall into. So there are countries that fall into those that are very favorable towards innovation, moderately favorable, slightly more favorable, slightly less favorable. And each of these circles represents one country. So that's Switzerland, for example, that is fairly favorable. On the other hand, there's Belize, I didn't even know that was a country. Paraguay, which is a lot less favorable, and so on. And explore what happens on a variety of different parameters. So on an innovation axis versus availability of technology, where do these zones stand? So where do the upper middle income zone countries stand, for example? And it turns out that Malaysia is one of the few that actually falls as an outlier into a different bucket, despite the normal characteristics. On the innovation index, they are a clear outlier, significantly higher than any other country, and one of the few of the developing economies that are landing into the bucket which is most favorable for innovation. Similarly, if I were to look at there was Saudi Arabia, that was point coming out as an outlier. Yeah, here we go. If I look at the axis of where are the highest number of perceived opportunities and where entrepreneurship is something that people like to do. Again, one of the countries that stands out as an exception in the sense that they are normally not doing pretty well on innovation, but the perceived opportunities in Saudi Arabia are extremely high. And, sorry, that is supposed to have been Namibia. Okay, where is Saudi Arabia? Yeah, here we go. But on the, well, firstly, entrepreneurship as a career option is extremely high in Saudi Arabia. And the perception of opportunities is also extremely high in Saudi Arabia, despite the overall technical innovation in Saudi Arabia not being as commensurate. Now, the reason this tool was created was not as much to do the clustering. The system could do the clustering. The reason it was created was to help people understand the implications of this clustering. Now, where we are, as I see it, is firstly, there are several patterns of analysis that we're finding. And these patterns of analysis are also automatable. So the role of the analyst is increasingly changing from executing analysis to interpreting analysis. This is made difficult by the fact that we have more black box models today that are accurate than white box models. And what's helping resolve that is an interaction with these models, visually and analytically, to help interpret what these models mean and how they work. What I'd like you to do is play around with your models, help people understand these models, rather than worrying about whether the model is as optimal as it can get. Models can optimize themselves. Don't worry about optimality. Focus on communication. It'll make a huge difference. There are more case studies if you're interested on our website, gramener.com. Please feel free to take a look at it. And this, I hope, will take you a step towards better communication of these models. Thank you.
Can I?
Yes, please.
Yeah. So, like you made this point of like analysts, the need of analysts to increasingly become interpreters. So, will we somehow see a movement like towards like domain experts actually start replacing data scientists in some form inside the company?
We're already seeing it. I mean, you saw in the panel discussion the focus on the importance of domain analytics, right? The analysis as a profession wasn't really a popular one 10 years ago. And at that point, the people that were doing analysis were the domain experts who needed work done. Now, what we're seeing is a sudden, somewhat temporary surge in data science, analytics, machine learning, and all of that. So it's becoming popular. But once that hype dies down, it will continue to be the domain people that need the analysis done, that will also be doing the analysis. That's on the one hand. On the other hand, there's also the growth of self-service tools. I mean, there were always self-service tools, right? Paper and pen is a self-service tool. It's a very good one. And the likes of Excel, Power BI, Tableau, and so on. And this will keep growing. And the people on the domain side will find that these analysts firstly can't understand what they're saying. These analysts can't explain things, for, even if they were tortured to death. They'll say, if they can't do what I want them to do, why don't I do what they're supposed to be doing and get into this space? And they're not going to be fussed about doing it the proper way or anything. They just want results. So they'll get the results. So the fact that today there's a shortage of analytics talent is a necessity for the people on the domain side to get involved in analysis. But they'll never be calling themselves analysts. They'll be doing their work and continuing to call themselves domain experts. Yes, please. You could try just speaking up loud if you want. I'll repeat the question. No, sorry. I'm not able to hear that.
Hi, thank you. So could you please let us know the technology stack used in the Gramener website?
I was hoping to avoid this question. So we built a visualization solution called Gramex. It's an engine that behind the scenes on the server side uses Python, on the client side uses JavaScript, and that's what creates all of these.
Are you using D3JS by any chance?
When we create network visuals, we use D3. When we create, let's say, circular visualizations, we use Circos. We pick among different libraries. But by and large, when we create them on the server side, which is about 80% of the time, we end up just creating the SVG directly.
Thank you.
Hi, I have a question. In your last slide, you mentioned you provide visual analytics services. Now with the rise of machine learning, you see tremendous applications. Think about an automated car. It can pretty much, the number of vehicles on the road, and if you can automate, you see a huge gain in terms of sort of productivity, if you want to call it. There is impact on the job loss, but when you think about the impact it can make in terms of increased productivity, it's huge. When you put that in the perspective of visual analytics, how much value the visualization create? I think it is an important mechanism to put forward your point, like explain the analysis. But as a data scientist, if you have to choose between visualization and getting into the machine learning, which would you choose?
So if you say that you cannot do visualization, you can only do analysis, or versus you can only do analysis, you cannot do visualization, or however you put it, right? If you had to choose between one and necessarily exclude the other, I would choose analysis, without doubt. Because a poorly communicated answer is more important than beautiful communication without content. So there's no doubt about that. Having said that, right now, the problem is that we have significantly more analysts who can't communicate than people who can communicate the results of good analysis. So the gap today is larger on the visualization side. So if today somebody says, what analytical technique should I learn? I'll probably, well, my first question would be, have you learned any? And if the answer is yes, then my next step would be figure out how to communicate that well first before you go on to more analytical techniques. Otherwise, you'll be wasting your time. Because what you would have done is gathered an enormous portfolio on the one side and nothing on the other. Sort of like a batsman saying, look, I can play any shot on the offside and you can't beat me on the offside. Then all that the bowler has to do is bowl a ball on the leg side and you're finished, right? So the obvious solution is not to practice anything on the offside more, practice on the leg side. That's exactly the same scenario here. There are enough people who know the techniques of analysis, and unfortunately that's becoming more irrelevant with the automation of analysis. Practice communication more.
Hi. In the marketing world, where we analyze a lot of sentiment data, consumers talking about us on all digital platforms, do you think we've been able to do a good enough job there? Because, a lot of customers say something else but do something else, and they say something else and they mean something else. So, your thoughts on that? And
one of my colleagues recently analyzed data, customer feedback for an auto company. And there were two columns. One that said quantitative feedback on test drive on a scale of 1 to 10. The other column was comments about the test drive. For years, our client had been analyzing the quantitative numbers, and they said the test drive factors are one of the most important drivers of the overall satisfaction. My colleague took this, put it into a sentiment analysis engine, and did the correlation, and finds that the sentiment of the test drive is the least correlated with the overall satisfaction. This made no sense whatsoever. So he goes back, looks at the data, and finds something weird. There isn't that much of a relationship between what people are saying in words and what they're saying as numbers. And if you look closely at the text, it's a fairly clear indication that the test drive is not that big a factor. What matters to them is the amount of paperwork that they're having to go through. That is one of the biggest pain points, and the variation in that is a bigger driver. What matters is the timeliness and quality of vehicle at that point of delivery. So when we go back to our client, the response is firstly, look, we have been in that, if this is right, then we have been operating under the wrong assumption all of these years, and that clearly needs to be changed, right? What we're finding is that when it comes to text analysis, the answer is not as much how good a job are we doing of it, as much as is it at all doing something. And even the slightest exploration of text is opening up a world that has not been explored so far. It is throwing out stuff that is counterintuitive to what has always been assumed. So in that sense, I would say, yes, it is doing a surprising job, surprising in the sense that it's effective in areas that we had not anticipated to be, but it is effective. On the other hand, in terms of the quality of output, in terms of the accuracy, so is this particular sentiment accurate? 80% of the time at best, which is not great. Do we even have the data? No. And if I were to compare, let's say, manual classification versus automated classification, where manual classification is even possible, obviously manual classification, not only is it more effective, it is also more cost efficient in some cases. Rather than the cost of building an engine that anyway somebody has to review, may as well just get the person to quickly review it, and people are able to, once they get the hang of it, review these things pretty fast. Yes, that is changing. In fact, the quality of sentiment detection is improving faster than the rate at which data is appearing. So things will get even better soon. But even in the absence of good quality sentiment detection, we're finding that plain text analysis is shedding light in areas that were not explored before, sometimes throwing counterintuitive insights, and therefore is proving worthwhile in those areas.
Thank you so much for that.